Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today is the day where we focus specifically on similar triangles. So we've talked about similar polygons, we've talked about similarity with circles. Now we're going to specifically focus on similar triangles. Before we get there though, let's do a quick review. So how do we prove polygons similar? What is true about similar polygons? And we could say in terms of angles and sides. And then 3, what is the process for proving two circles similar? Is it always the same process? So answer those 3 questions as a bit of a review, and then come back and see if you were on point. Okay, so for number 1, how do we prove polygons similar? We map them together using a series of transformations. And the 3 that we can choose from, the 4, reflections, rotations, translations, and dilations. What is true about similar polygons in terms of angles and sides? Corresponding angles are congruent, and corresponding sides are proportional, which means they have the same scale factor. The process for proving two circles similar. Well, map their centers together using a translation, then dilate one circle so it is the same size as the other. And then if we have done that, the circles will be completely mapped onto one another, proving that they are similar. Okay, let's move into triangle similarity. So far, to prove polygons similar, we've had to show that every pair of corresponding angles were congruent and every pair of corresponding sides having the same scale factor. However, just like there were shortcuts for proving triangles congruent, there are also shortcuts for proving triangles similar. And we're going to learn about three different ways. So again, just to recap, initially, we had to look at all 3 sets of angles, make sure that they were all congruent, and then we had to check the scale factors for all 3 sets of sides. Now, we're going to see that that's not necessary, right? Just like with congruent triangles, we had some shortcuts. Similar triangles provide some shortcuts as well. The first one is just AA, angle. This is definitely the easiest one. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. We don't need to say anything about the third set of angles, and we need to know nothing about the sides. So as long as 2 angles are congruent, we know that the triangles are similar. AA criteria. Second criteria, side angle side, SAS similarity. If 2 sides of one triangle are proportional to 2 sides of another triangle, and their included angles are congruent, then the triangles are similar. So again, we just have to make sure that the angles are in between the 2 sides that we are looking at. We also have to make sure that there are these 2 sets of sides have the same scale factor. So what we need to do, we need to add something to our hypothesis here. We need to say that, and we'll assume that this is the image, and over here we have the pre-image. So we would also need to know that DE, the ratio of DE to AB, was equal to the ratio of AF to BC. All right, so both of those ratios need to be equal, as well as angle B and angle E being congruent. Then we could say that the triangles are similar. Third one, SSS similarity. For this one, we need to know nothing about the angles. We just have to make sure that all three sets of corresponding sides are proportional, that they have the same scale factor. And again, we already talked about this, but if you're unsure of, well, how do we match up the sides? Well, you go smallest and smallest, right? Middle and middle, and large and large. And that's how you set up your ratios. So you can use any of these three. All three of these will prove that the triangles are similar. Let's do one of these, I think. Let's see. Let's do number 4. So we need to prove that these triangles are similar, and then we'll also write a similarity statement at the end. So I'm going to let you guys pause the video, think about which of the criteria could we use here, and what is everything we would need to show to prove that criteria. Okay, so right away we see 2 sets of sides, so we're probably going to be using SAS if it's possible, because we don't have 3 sides, we only have 2, and we don't know anything about all of the angles, or 2 angles, but there may be something we can figure out about one of them. So the first thing I'm going to do is look at the sides. And I'm going to compare the smallest. Let's actually highlight these triangles. So I have my red triangle, and I have my pink triangle. So I'm going to look at the smallest side of the red, which is 12, and compare that to the smallest side of the pink, which is 16. So it doesn't matter which order you do it in. I'm just going to do 12 over 16. You could do 16 over 12, that's fine. Now, is that the same as 15 over 20? Well, common factor of 12 and 16 is 4, so that gives me 3/4. Common factor of 15 and 20 is 5, that also gives me 3/4. So we've proved that 2 sets of sides have the same scale factor. Now we just need to figure out these angles. Is there a way for us to prove that these angles right here are congruent? Well, of course there is, by the vertical angle theorem. So I can say angle TXU is congruent to angle VXW. We do need 3 letters here because there's multiple angles surrounding X by vertical angles theorem. Thus, SAS is the similarity criteria, and now we just need to write a similarity statement. So I'll start with the red triangle. We'll do TXU. Now remember, side TX was corresponding with VX. So if TX comes first, that means VX is coming first for the pink triangle, so VXW. And there is our similarity statement. Okay, we'll get to the rest of these in class. I am going to... You know what? No, we're actually going to cut the video off here. We're also going to do the proof in class as well. So if you want to get a head start, feel free to work through the rest of these problems. You can attempt the proof if you want. Again, just like we have proofs for proving triangles congruent, we can write proofs for proving triangles similar. But we'll keep this video short for today. And if you want to get a head start, you can, but we'll work on the rest of them in class. All right, enjoy the rest of your day, and we will look forward to seeing you next time.